Now we're going to look at pattern recognition. Being able to recognize patterns is a huge concept in algebra. So what we're going to do here is we're going to figure out how we can come up with some expressions that would represent the number of tiles, either the number of gray tiles or the number of white tiles that you see in a figure. It's very algebraic in thought and developing patterns and trying to figure out how the position plays into the number of tiles that you see. So we'll try to be very systematic about this. I'm going to set up all these problems with a table because I think it makes it easier to organize our thoughts. So the questions are going to say how many gray tiles are in the nth figure, meaning any generic figure, and how many white tiles are in the nth figure. So maybe the 20th figure or the 50th. Could we come up with some sort of a little expression that could help us figure this out? So the first thing we need to do is we need to assign positions, and I'm going to use n as the variable. So this is the first position. Right? It's the first set of tiles. So that's n equals 1. And then this is the second one. And then the third one, etc., etc. So in my table, I've got 1, 2, 3, and then eventually we'll get to the generic expression with n. So let's just look at the gray tiles to start with. How many gray tiles are in the first position? Well, there are 2. In the second position, there are 3. In the third position, there are 4. So if I added another picture, it would have 5 gray tiles, and then 6, and then 7. So you can see the pattern. What you want to do is look at how the number of tiles compares to the position. How can you get from n to the number of gray tiles? So what could I do to 1 to get 2? What could I do to 2 to get 3? What could I do to 3 to get 4? You'll notice that the number of tiles is always 1 more than the position. So the gray always seems to be 1 more than the position. So how do we say 1 more than n? We say n plus 1. So the number of gray tiles, an expression for that, is n plus 1. It's the position it's in plus 1. So first position plus 1, second position plus 1, third position plus 1. And so now if I wanted to know how many gray tiles were in the 100th position, I would know. Now let's kind of play the same game with the white tiles. So with the white tiles, in position 1, there's 2. In position 2, there's 4. In position 3, there are 6. And if you follow the pattern, the next one would have 8, and then 10, and then it's even numbers. So again, what could I do to 1 to get 2? What could I do to 2 to get 4? What could I do, like adding, multiplying? What could I do to 3 to get 6? Well, it seems like the number of white tiles, is always the position doubled, right? If you take the position and double it, take the position and double it, take the position and double it, that's the number of white tiles. So n times 2, or 2n. So when n is 1, there's going to be 2 white tiles. When n is 2, there's going to be 4. When n is 3, there's going to be 6. So again, it's using this position in your little expression. So that's how many gray and white tiles you would have for this particular pattern. So let's look at another pattern. So again, I'm going to assign positions. So position 1, position 2, 3, 4. Now in this one, I'm going to do 4 here. Instead of my ... row, I'm going to do 4. So let's do the same thing, play the same game. How many gray tiles, how many white tiles in the nth figure? Okay, so for the first figure, there aren't any gray tiles. So there's none. In the next figure, there's 1 single solitary gray tile. In the next one, it's a little 2 by 2, so there's 4. The next one is a little 3 by 3, so there's 9. I bet the next one would be a 4 by 4, then a 5 by 5, then a 6 by 6. So you see how these are perfect squares? 0, 1, 4, 9, 16, 25, 36. That's how this would progress. And you have nothing in the first one. It's like a little 0 times 0. It's like a little 0 square in the middle. And this is a little 1 by 1 square. And this is a 2 by 2 square. And then a 3 by 3 square. I'm just trying to like figure out how the shape that I see, the square, can help me figure out what the pattern is. So look at the position and look at the number of tiles. Position, number of tiles. Position, number of tiles. What you notice is it's not 1 in position 1. They're using 0. For position 2, they're using 1. For position 3, they're using 2. For position 4, they're using 3. So they're always using the one before. Well, how do we say the one before n? It'd be n minus 1. So you take the position and subtract 1, and you square it. And I think it's really, really important to see that we call that squared, and the literal shape is a square. I mean, that's why it's called a square. So this is the number before n squared. So number before n is n minus 1, and then we square it. Let's see if we can figure out the white tiles. So in position 1, there are 4 white tiles. In position 2, there are 1, 2, 3, 4, 5, 6, 7, 8. Then there are 4, 5, 6, 7, 8, 9, 10, 11, 12. I bet the next one would be 16, and if you count it, it is. And then 20, and then 24. Do you see how we're adding 4, adding 4, adding 4, adding 4 each time? But we want to relate it back to the position. So what could I do to 1 to get 4? What could I do to 2 to get 8? What could I do to 3 to get 12? Okay. I know we were adding 4, but it sure looks like we're multiplying each position times 4, and we are. You're adding 4 from position to position, but we're actually multiplying by 4. So if you take the position and you multiply it by 4, you'll see the number of white tiles. So we can see that these are n times 4, which we can write as 4n. And that's how you can use a table and the shapes themselves to kind of help you figure out the algebraic expression that you could use to represent the number of tiles.